working with algebraic expressions basically the whole, last 2 months? It's been almost 2, guys. It's basically we've had 2 months of school. Now we're getting to the point where we're starting to solve equations. Now, here's the thing. You can't have an equation unless there's what symbol? Equal sign. You can't solve anything unless there's what symbol? An equal sign. So now we're to the point where now we're going to use all the skills we've been using to actually solve equations. Now, here's the thing. When we work with this in math, we use our variables to represent numbers normally, correct? Now, guys, we use variables, but you don't have to use variables. You can use any other lovely symbol that's out there. So a lot of times we usually use like X. So boring. But guys, you can have things like theta, alphas, you can do betas, you can do, basically, you could do Christmas tree. Long as you define the symbol, you can use it. Yeah, you can totally use it. Any of the funky symbols like that. So here's the thing you need to understand. When we are working with it in this class, it is going to be understood that we are solving for some sort of numbers, okay? A lot of times, real numbers. They can be integers, decimals. They could be irrational numbers. But most of the time, we're going to be looking for real numbers unless they tell you otherwise. But here's the deal. If we don't make that assumption, what we're doing means nothing. Unless you really, truly define what your variable is, it absolutely means nothing to do that. So, here's the cool part about this. I'm not sure why this thing has shrunk to the degree that it has. Are you going to let me? This is the weirdest shrinking thing that happened. Will it let me make this bigger? Nope. But I'm having a lot of fun playing with this. See if I can pause. I'm feeling a little bit better because it was recording such a weird size. So, here's the thing. We have to make sure that we're just solving for it to make it true. Now, here's some terms that you need to understand. When you're solving for a variable, we call it a couple different things. We call it solutions or roots of the equation. And to do that, you solve the equation. So please understand, if I say find the roots of the equation, or I say solve the equation, those are synonymous. You know what synonymous means, right? And don't ask me to say that word again. It's not happening for the rest of the year. Nope. So they're going to be equal to each other. So guys, here's the thing. When you have the type equations we're using now, they're called linear equations. Now, talk about it. We did work with polynomials for a reason. We talked about them being trinomials, quadratics, binomials. We used the idea of linear. When do you have a linear equation? Friends, when your exponent is what value? Linear equations are when your exponent has what value? It could be negative, but most of the time it's positive. It just has to be what value? 1. So when your variables have a first power, so to the first, you know you're working with a linear equation. So notice with that x, because the x is our variable, it's what power? All right, someone goes, what if we had multiple variables? Let me remind you of something. What if you had something like this? 3x minus 5y equals 15. Isn't that the standard form of a line? It's still a linear equation. Because what are the degrees for both of the variables? 1. Are you guys staying with me on this? So we're not changing the rules, but just if you have something that's linear, the degree value is going to be what? 1. Okay, now we're good. Okay. Now, guys, if we don't know how to do some of this stuff, I'm going to cry. So we're going to just make some big assumptions that you learned Algebra 1. Is it fair that I make that assumption? Okay, here's the assumptions that you need to make. Friends, I'm going to show every baby step today. I am not after this because you're supposed to be at the point in your math career that you don't need every baby step, but you do have to show work. You may not write an equation down and go straight to the answer. Because look at me right now. I wouldn't believe you. All right? You got to prove to me you know what's going on. Now, the good old days way back. Like, doesn't this just bring me back? And this is solve. We never could say solve before. Everything has been evaluate or simplify so far this semester, but now we can solve. Guys, what would you do first for this lovely two-step equation? All right, so the good old days, you subtract 7 from both sides. You get 4x, guys, no distractions, thank you, equals 12. Remember the good old days? We made you line everything up. Some of your Algebra 1 teachers would do this with the line. You know what I'm talking about? Okay, people, if you just line things up, you don't need that, right? So then what would you do next? So divide by 4. Now, I actually tell people you might want to get in the habit of doing this because guess what last year a whole bunch of you would do? A whole bunch of you would divide both sides by 12 instead. Oh no! Oh no. People in this room are guilty of this. Last year I'd be watching them solve problems in geometry. And people would consistently do it. So, x is equal to 3. Now, how do we know if that is a root or solution of the equation? Plug it back in. Now, everyone goes, ooh, we all live for this, right? We all sit there and do what? Do it real quick. But no one loved checking the equation. But guys, there's no reason why you shouldn't be able to do it, especially if you have time when you're taking a quiz or a test. So this would be 12 plus 7 does it equal 19. And then we get 19 is equal to 19. Hey, did it check? Yes. Now, here's the thing. How would I actually expect you to show work on something like this? Because you should be at the point in your math career that you should be able to do a little bit of this in your head. Would you agree? So here's what I'd want to see. First of all, if you don't write the original equation down, what are you thinking? Okay? The problem should be down. But doing the same thing, you should be like, hey, I subtract 7 from both sides. My next step is 4x is equal to what? 12. Then you can say, okay, now to solve that, I divide both sides by 4. X is equal to 3. Okay, did we get the same thing and did you show your steps? Yeah, I'm fine with that if you're good at it. But if you're not good at it, should I see work? Show a little bit more. Here's the rule that's always been with me. As long as you get it right, wonderful. But if you're getting it wrong, show the darn work. With me? No skipping to n solutions on here. All right, let's look at the next one. We have 3 times the quantity x plus 2 minus 5 times the quantity x plus 2 equals a negative 2x minus 4. Now, is this really a hard equation either? No, but guess what? People in this room will mess it up. If I asked you right now to do it, a large group of you would sit there and make a silly little error that would destroy it. So I'll tell you about it as we go. Are you guys with me on this? Okay. So on the first one, what I noticed is some of you don't understand this wording. Simplify before you move sides. Don't move anything from either side right now until you truly, on the left-hand side, get it as condensed as you possibly can. So what do you have to do first? Because order of operation comes in. What do we have to do? Distribute. So we're going to distribute the 3, and we should get 3x plus 6. Now, what do we distribute next? A negative 5, not a what? Now, this is where it always goes wrong. I don't know how many times people start off strong. They will sit there and go minus 5x, and then this will be the very next thing they write down. What did they do? Oh, no. I've watched you guys do this year already. Okay? So, I didn't say you. I just said I've watched people in this room do that this year. Correct? So, friends, do not be that person. Now, notice on the right-hand side, it's already simplified. I'm not touching it yet. This is when all of a sudden people think it's time to start moving things. It's not simplified. Don't move. What do I have to do next to simplify the left side? Combine like terms. Guys, what's 3x minus 5x? What's 6 minus 10? Okay. Now, so when we're looking at this, and it's exactly the same. A lot of people, if they're in a rush, don't realize that. But we do the normal math, right? We're like, oh, we put the constants on the same side, the variables on the same side. So what do we add to both sides? I can add 4, and then what do we get? A negative 2x equals what? A negative 2x. Wait a minute. What do we do next? Divide by a -2. What do we get? X equals X. Now someone goes, wait, I can get X's on the same side. Okay, get X's on the same side. What do I subtract an X from both sides? I get 0 is equal to what? What happens when your equation is 0 is equal to 0? What's your answer? Nope. It's not undefined. It's a no solution if you have two separate numbers. So like if you had like 3 is equal to 5. That's no solution because it's not true. But is this true? All right. No. So when you get the fact they are equal, okay? So let's write this down so you remember this. When the end statement, okay, is true, where you get a number equal to a what? The same number. Are you guys with me? This is true. How you'd write your answers, ready? All real numbers are solutions for a what? For the variable. So guys, think about when you got to this spot right here. Could I put any number in and is it true? Yes. Could I put an icky number or a nice number? Yeah. So how do we write that down quickly without having to be too fancy? That's the fancy algebraic way of saying all real numbers. So you write an R and then you put an extra segment to the left of it. Now, how do I know if that's true? Check any what? Yeah, use any number you want. Everyone pick a different number than the person next to you. Not the whole class. So pick a number different than the person next to you and then check it. So, like for instance, I'm going to use something like 7. You know, I'm just going to go let x equals 7. Someone let it be like 2. Someone else, you can make it a decimal if you want, 0.5. Do a negative. Someone pick a negative number. But it should work no matter what we pick. But put it in. So we go here, 7 plus 2. Shh, less talk, more work. I asked you to pick a number and plug it in. Can you please do so? Oh, the 3 on the first one, thank you. You pick a different number than me, please. So this is 3. Wow, I can't do my math. Better do my math here. All right. Pick your different numbers that you got. What number did you use? All right, I have 2. Did it work? All right. I did 7. I got negative 18 is equal to negative 18. Did anyone pick a negative number? What did you get, Jack?
I did negative 3 and I got 2.
All right. Other numbers. Guys, notice it didn't matter. Could I put pi in there? Yeah, I did pi. And guess what? It would still be true. So the cool part about it, if you get it down to where it is 2 numbers equal to itself, or 0 is equal to 0, you are going to have all real numbers are a solution. Now, if you ever get to a solution where it's like 3 is equal to 5, or they're 2 separate numbers that are not true. Notice I didn't put a variable in there, right? That's no solution. Are you guys with me on that? So you can get no solutions as well. All right, let's look at the next one. Remember fractions. Do they go away? All right, so we're still going to be able to solve. This is still a linear equation. Just because it looks with fractions doesn't mean the rules go out the window. There's a reason why we've been doing everything with fractions. But the first thing I would tell most of you is you're not going to do well with that R right there. Rewrite your equation first. Guys, how could I rewrite this so it makes sense? What would we rewrite? We go 3/4 plus what? Jack. 4/4 plus, come on guys, rewrite it. No, where would you put r? Are you going to put it on the side? No, where are we going to put it? On top. And then you go minus 1/2 equals, and then you got 4/5 r. Don't write it that way. Where should you put the r? On top. The first thing you should do is realize when you're multiplying that together, r needs to go where? On top. Now, working with this, I'm going to rewrite my 3/4 so this looks a little bit prettier. What should we do? Now, you can do common denominator. Do I want to work with fractions? How many of you are like, ooh, please, let me work with fractions? No, but can I use the common denominator to my advantage? Could I multiply everything by the common denominator to get rid of the fractions? Yeah. So you guys said, what is your least common denominator for this one? What did you guys pick? 20. So it's 20. So if you're going to do that, please note, if I do something to one side of the equation, don't I have to do it to the other? Otherwise it doesn't stay what? Balanced, correct? So guess what I'm going to do? I'm going to go 20 times 3/4 plus r over 5 minus 1/2 equals 20 times 4r over 5. All right, now what do we have to do? Distribute. So let's do this real quick. Guys, what is 20 times 3 divided by 4? It should be 15. Exactly. Now here's the hint. Could you divide by the 4 first and then multiply by the 3? Yeah, either way. So this is going to be 15. What's 20 times r over 5? Yeah, very good. How did I get 4r? 20 divided by what? 5, right? Guys, do I need to show the in-between step there, or are you following just fine with me? Because I can show the in-between step if you need me to. Don't be afraid to ask for that. All right, then we do our last one. 20 times a negative 1/2. Well, guys, what's 1/2 of 20? 10. So it would be a negative what? 10. All right, now the same thing here. We got 20 times 4r divided by 5. So you should have the fact that 20 divided by 5 gives you what value? 4. Well, what's 4 times 4? So that would be 16r. Guys, would this be one of those times that if you use your fractions, your calculator help you with fractions, would that probably be okay? But should I be able to do this without? Yes. All right, now I still can't move sides because I'm in simplest form yet. All right, so when we put this together, we get 4r plus what? 5 equals 16r. What do we do next, my friends? Subtract 4r. So 5 is equal to 12r. Then what? Now, I think for most people it's still smart to do this. R is just equal to what value, my friends? No, 5 over what? 12. Now, how do you know if you're correct? You must do what? Just check it, right? Can we plug it in? So let's do this real quick. So we got 3/4, and then we're going to go plus 1/5 times 5/12 minus 1/2. Does that equal 4/5 times 5/12? Well, let's do some simplifying over here, my friends. That becomes 4 over 12, which reduces down to what? 10. This is when your calculator comes in really handy, would it not? Put it in with the fraction format. Well, exactly what you see here. Guess what it ends up being? 1/3 equals what? 1/3. Now, I told you, you could use your calculator to check, but did I show what I'm plugging into my calculator? Yeah, I'm okay with that. Because you're checking. Are you with me? But make sure calculator functions. If you do it with division sign, it's going to go bad. So don't do that to yourself. Keep it so it looks exactly what we have on the screen. All right, is this drawing memories back? Yes, ma'am.
I had a quick question about how you got 15, like once you applied 20 to all of the...
Which one? Oh, 15? All right, so 20 times 3 is 60 divided by 4 is 15.
Oh, okay.
So you're multiplying it to the numerator and dividing it by the 4. But I knew it's easier to go 20 divided by 4 to get 5 than 5 times 3 is 15.
Okay.
It's just quick multiplying. No, that's why we want to ask the questions now. Guys, be careful. Now look at this one. What would you do now that we've done that other one? What would we do? Should we rewrite it? Yeah. What's going to be our values? X6 plus 2/3 equals what? Yeah, 3x over 4. Okay. No one likes fractions, so what? Yeah, multiply by the least common denominator. Do you understand why we did least common denominators first? All right. So our least common denominator is what value? 12. Excellent. So we're going to multiply both sides by 12. Now, for some of you, you can maybe think of it as 12 over 1, just so it helps you kind of think fraction format, right? So anything that helps you not mess up fractions, I'm here for you. All right, so let's do this real quick. What is 12 times x over 6? What does that reduce down to? 2x, right? Because the 6 divides into 12, so it would be 2. Okay, what do we get for the next one? 12 times 2/3. Yeah, because 12 times 2 is 24. Divided by 3 is 8. Awesome. Then we have 3x over 4 times 12. Now, this is why I want you to be good at fractions, because now we know how to get rid of them. Correct? Now, are we in simplest form so we can start moving sides? So now that I can't do anything on more on either side, now we start working with it. So what would be the thing that naturally most of you would go ahead and do? Yeah, 2x. So we get 8 is equal to, and then do what to both sides? Yep, divide by 7. X is equal to 8 over 7. Now, again, is our calculator our friend to check our work? Absolutely. Because what would we do? We'd go 8/7, and I'd plug it back in here, and that's 6. So literally I have 8/7 over 6. Plus then I have my 2/3. And then in the original equation, what do we have? We have 3/4 times what? 8/7. Notice I went back to the very original equation and plugged this in. Would it be wise to let the calculator do the work for us? Guess what? Guess what the calculator tells you? Yeah, it's the same thing. In fact, you'd end up getting on this 6/7 on both sides, and it would check. Yes, sir.
I was gonna ask, can you do 1/6 times 8/7?
It's the same thing. Yep. All right. Question? Yes. Other questions? Are you guys following with me? Okay. Now, if you can do this next one, I think you guys are totally rocking fractions beyond my imagination. I'd be the happiest teacher. Now, here's the problem. Sometimes the answers don't work. Sometimes you're going to get multiple answers, especially when we work with quadratic equations. Sometimes you're going to get one. But the reason why we check is because sometimes, literally, no matter what we do, even though it looks pretty and we come up with an answer, it doesn't work. And those are called extraneous solutions. They're extra what? Answers. Does that make sense? And they don't work. So I'm going to give you an example of an extraneous solution problem. This is something that you have to check when you have variables in the denominator of fractions. When do you need to do this? When you have variables in the denominator of what? All right. Always check if variables are in the denominator of fractions. Because if you don't, you are going to miss solutions. What? Yeah. All right. So let's look at this first one. Here's an example of this happening. First of all, wouldn't I put that 2 over 1? And the reason why I would do that is just to make my brain think everything has a lovely what? Fraction. Okay, so we get here. 2 over 1 plus 5 over x minus 4 equals x plus 1 over x minus 4. Oh, look, I have fractions. I don't like fractions. So what do we do? Multiply by what? Oh, did I just hear it? Least common what? Sounding familiar? Why we had to do this yesterday? So what is going to be my least common denominator for this one when I have my values are 1 and x minus 4? This is going to be x minus 4. So what are we doing? Well, we're really doing this. So we're going to go x minus 4 is really getting multiplied to 2 over 1. And then we go plus. And we also know that 5 over x minus 4 is getting, I should put that in probably 5 here. 5 over x minus 4 is also getting multiplied by what? X minus 4. And then our lovely fraction over here, x plus 1 over x minus 4, is getting multiplied by x minus 4. And guys, if it helps you to put this over 1, put it over what? 1. For many of you, it helps. Okay, let's look at the first one. Try and multiply those. Yeah, really does not become 2 times quantity x minus 4. What happens on my second one right here? The 5 over x minus 4 times x minus 4. What happened? Yep, they simplify out to be 5. How about our next one? Our x plus 1 over x minus 4 times x minus 4. What happens there? And we get x plus 1. Okay, now it's a simple solving equation. Don't do anything until you finish simplifying on the left-hand side. So we distribute. We get 2x minus 8 plus 5 is equal to x plus 1. Are we in simplest form yet? On the left side? No, because we have to combine like terms. So we get 2x minus 3 is equal to x plus, oops, make sure I put my values down, 1. Then, now we're in simplest on both sides. We keep solving. We add the 3 over, so we get 2x is equal to x plus 4, and then we subtract x. We get x is equal to 4. All right, so far it looks pretty. Do you guys agree? Look what happens when we plug it in. So here's our 2, and we have our 5. What do we put in for x? 4. And I'm doing this just to show you where this is going to go. And I get 4. You can do this all in one color, by the way. I'm not over. I'm going to go 4 minus 4. Guys, look what happens here. I get a 2 here. Then I get a 5 over what? And I get another 5 over what? Can I divide anything by 0? So, remember, one reason why we have to check it with fractions is if I plug it back in the original problem, notice I'm going back to the original problem, I can never have what in the denominator? I can never have 0 in the denominator of a fraction. You can't put something into 0 piles. Do you guys agree? So the fact is, you can't have that. So what do I know about this problem? No what? Notice it said no real solution. No rational or irrational number, integer, whole number, natural number are going to work. So you always have to check solutions. Now, I think we can do this one, guys. I think we can have here at 20 something. I have no idea. This new schedule is killing me here. What do you get? 22. Yep, we can do this next one. But we have to be efficient. Can we be efficient?
Yes, for sure.
Okay. So, scholarly ones. Anyone see something here? I see a trinomial. I see binomials on the other fractions. How do I make things the same? How can I make it so I can work with this a lot easier? Get a common what? All right. So shouldn't I factor this first right here? All right. Is there a GCF? How many terms? All right, guys. What does x squared minus x minus 2 factor into? So x minus what? And x what? Because if I check it, negative 2x, positive 1x, do I get a negative x? Okay, why did I do that? Because have you even gotten rid of fractions this whole time? I need a common what? All right, so what's our LCD? Yeah, I'm going to have to get a common denominator in all of these. Now, not all of these, I should say multiply by our common denominator. Would you guys agree? So on to the left, I'm going to go x plus 1 times x minus 2. And let's just do this so we can keep track of our brain that we're working with fractions. Times what? 1 over x plus 1 minus 1 over x minus 2 equals, I have to do the exact same thing over here, do I not? Times our x plus 3. Now notice how I'm rewriting this. My x minus 2 to my x plus 1. I'm keeping it in the factored form because is it easier to show? It cancels out. Yeah. So here's the cool part about this. Let's distribute. If I distribute to the first value, what simplifies out? Our x plus 1. So what gets left? What did we get left? X minus 2. Would you guys agree with me? It's what gets left. Do I need to show this step in between? Because I'll show this step in between if necessary. All right, let's finish this one. No. Guys, I would make this a negative so this would make your life a lot easier. What is negative 1 going to be multiplied by? Because the x minus 2's would what? Cancel out, so we get x plus 1. Okay, on this side, does anything simplify out? Do they both go away? Which leaves what to be here? So we got x plus 3. Okay, can we now make sure this works? Yep, so we simplify. So we get minus x minus 1 equals x plus 3. Guys, can we combine like terms? Yeah, if we combine like terms, what do we get here, my friends? So it should be a negative 3 is equal to what? Did I add a negative sign that I should not have? Hold on, guys. That shouldn't this be your positive one? Hey, this is an easy fix at least. Woo! So it should be what? I wanted to do with the negative sign. Why did I want to make it harder? I don't know. All right, guys, I did not dismiss you yet. Let's finish the problem. Guys, you have 10 minutes. You'll get to chapel on time. Thank you very much. So what do we get here? 2x minus what? 1 equals our x plus 3. Now what did you guys do? Now can you move sides? What do we get? Subtract x?
Yeah.
Okay, so x minus 1 is equal to 3. X is equal to what? 4. Here's how, you guys want to know the shortcut way, how it works? If I plug 4 in to any of these, does it make a 0? If I plug 4 into the denominator of any of those fractions, will it make a 0? No. So guess what? It works. All right? That's the fast way of checking. Not that I'd ever teach you shortcuts ever like that. Why would I do that? Guys, good job today. Let's do all the problems and homework. Probably the last couple I expect questions on because that's were the ones at the end. Pretty intense homework, as you know, notes.